is another example from mesh analysis. Here, as you can see in the question, we want to find I0. And I0 is the current that's passing from these 10 ohm resistors, and as you can see, we have a dependent voltage source in here, which is equal to 4I0 also. So the first step is say we're gonna define one current per mesh. We say I1, I2, and I3. And we're gonna start one by one for each mesh writing the KVL equations. And then at the end, from having I1 and I2, we can find I0 easily. So here we say in mesh 1, our current one, if we write the KVL equations, we start from here, minus 24, because we're entering from the minus side, so minus 24 volts, plus 10, multiply the current here. We said if we're writing the current for a resistance which has two currents going and coming out of it, we say the current is the current of the mesh we're in, which is I1, minus the current of the other mesh, which is I2. Plus, here we have another resistance, 12. So we say the current of our mesh, which is I1, minus the current of the other mesh, which is I3, is equal to 0. Get back to our point we started. So if we simplify this equation, we get 22I1 minus 10I2 minus 12I3 is equal to 24. Goes to the other side, it's getting minus 24 becomes 24. Here we can multiply this by 1 over 2, which gives us 11I1 minus 5I2 minus 6I3 is equal to 12. So this is our first equation here. We have three different variables we don't know, and because we have three different meshes, we can find three different equations for these three different variables. Mesh 2. So I start from here. We have a 4 ohm resistor. The current is the current of our mesh, which is I2, minus the current of the other mesh, which is I3, plus 10 multiplied by the current of our mesh I2 minus the current of the other mesh minus I1. So if we were in this mesh, it would be I1 minus I2. Now that we are in this mesh, we say I2 minus I1. And we explained in the previous videos why. Plus, next one is this 24, which the current is only I2. Then we get back to our first place, so we say this one is equal to 0. If we simplify this, we get minus 10I1 plus 38I2 minus 4I3 is equal to 0. We multiply this by 1 over 2, so minus 5I1 plus 38 by 2 is 19I2 minus 2I3 is equal to 0. So this is our second equation. Mesh 3. Starting from here, we have a 12 ohm resistor. The current is our current I3 from this mesh minus the current of the other mesh minus I1 plus 4 again our mesh I3 minus the other mesh current I2, and here we have a 1 voltage source. We are entering from the plus side, so plus 4I0 is equal to 0. So here, in order to find this number, because we're gonna have this I0 is gonna be a fourth variable, and we can only have 3 equations. So in order to make this equation only with our own 3 variables, we are using NOT analysis, and we say that in our NOT analysis at NOT A, we said the currents that going to the NOT, which is I1, are equal to the currents coming out of this NOT, which are I0 and I2, because This is I1 and this is I2. So coming out, this is coming in. So these are equal to each other. So I0 alone is I1 minus I2. So here, instead of I0, we put I1 minus I2. And we simplify this. We get minus 8I1 minus 4I2 minus 8I2 minus 8I2 plus 4 plus 16I3 is equal to 0. So minus 4I2 minus 4I2 and okay. 4I2, yeah, 16I3. Correct. So this is also this, we multiply this by 1/8, so it's minus I1 minus I2 plus 2I3 is equal to 0. This is our third equation. And then if we find this 3, then we find I1, I2, I3, we can easily find I0, which is originally in the question is asking us to find. So I write the matrices for this equation. The matrices tells us, we say I1, I2, I3, so we have them all in the same order. And then we write 11 in the same one, minus 5, minus 1, minus 5, 19, minus 1, minus 6, minus 2, and 2. I1, I2, I3 is equal to 12, 0, 0. And I showed you in other videos how to do this on this calculator. I'm gonna be calculating it really fast in here. So 11 minus 5. So our x is I1, this first variable I1 is 2.25 ohm. Why is it, sorry, ampere? Why is it ampere? Because we have the voltage is in volt and the resistance is in ohm, so the current is gonna be in amperes. Y is our second variable, which is I2, 0.75 ampere, and the Z is gonna be our second current, I3, 1.5 ampere. So we want, in the question we want I0, and we know I0, we wrote here from our node analysis that I0 is I1, which is 2.25, minus I2, which is 0.75, which is 1.5 ampere. So this is our